look like a FOSDEM volunteer. You look like a FOSDEM volunteer.
Ja, dat zeg je. Espero que salga muy bien la charla. Sí, yo.
Hola, Roberto.
¿Qué tal?
¿Qué tal? ¿Cómo estáis? ¿Estáis preparados? Are you ready?
We'll see.
Questo effetto affiliato nuovo è affiliato ai 5.000 persone. Quanto sarà?
No, 1.500. Quindi se facciamo un terzo su 500 persone
Va benissimo.
Ah, che bisogna...
Per me è 11-1,
Sì, sì. 11. Vai, 11.
Ricordi for about your time?
Okay. Should we go? Okay. So hi everybody, it's a pleasure to be here today. I'm Roberto Di Cosmo, Stefano Zacchiroli. You probably know us for our long history in free software before, but we are here today extremely excited to tell you about a new project that is taking up basically all of our energy. It is called Software Heritage, and we are basically building the Library of Alexandria of source code. But before going into the details, let me give you some motivation. So if we look around us, we see software everywhere. It powers the digital transformation, it fuels our innovation, it's an essential component of model research, it's an essential mediator for accessing digital information in any shape, and you think about it, we use it everywhere from communication, entertainment, politics, the way you are organizing politics depends on software. So in some sense, software embodies a significant part of our knowledge and our cultural heritage. But as we know very well in our community, when you talk about software, there is one thing which is really the knowledge, and this thing is a source code. The source code of the software, which is a very special object in human history. If you think about it, it is human readable, executable knowledge, which is a first kind in human history, a kind of an object like this one. As Harold Abelson, who was he is a fantastic teacher, he wrote a book I was using when I was young and university. He is also, by the way, one of the founders of the Free Software Foundation of Creative Commons. He used to say that computer programs should be written in the first place for people to read and only accessorily for machines to execute. They should be, I mean, this is a recommendation for students, of course. And now if you look at the incredible amount of free software which is around, now you have access to pieces of code which are beautiful. For example, look at the source code of the Quake 2 game, which was released, the free software, many years ago. Well, it is not very readable here. I do suggest you go and read it over the internet. There are fantastic pieces of hackery on how to make this 3D animation work on machines which are not powerful enough. There are incredible tricks in the Linux kernel, for example. And to understand what is really going on, you need to go and read the source and read the comments that are in there. As Len Schuster, who is the founder of the Computer History Museum, says, having access to the source code of our software is actually an incredible open window in the mind of the designer. And if we think a little bit about this a little bit more, I mean, this is actually, I mean, our free software are really the software commons, our software commons. But what are the commons? Well, the commons are basically resources which are held in common that are not owned by anybody in particular, but that everybody can use freely. We are used to this in economy, air, water, something like this. If you think about software commons, I mean, this is the software that is held in common that everybody can reuse, adapt, and so basically everything which is free and open source software is a software commons. But unfortunately, if you think a little bit about it, you know that from economy, when you have something which is held in common, you often have what is called the tragedy of the commons. I mean, if you don't care about your commons, if you don't nurture the common, if you don't cherish the common, they will eventually perish. We know this. That's the reason why, as a community, we are very active trying to maintain our software, make sure there is a community taking care of it, making it evolve, getting new people on board, sharing our principles and values. That's very nice. But if you look at our source code, I mean, this is really a precious part of our knowledge. Are we really doing everything necessary to make sure it is maintained over time? Well, not really. There are a few issues we need to face. One thing is that, of course, software is everywhere. That's positive. But software is also spread all around, and that's an issue, because we are actually using many, many different disparate platforms for developing software. We are strongly opinionated people, so I use mine, you use yours, everybody uses their own preferred development platforms. Here in this tag cloud, I have just highlighted some names that should ring a bell to all people like me that use the platform that more or less disappeared today, and other names that should ring a bell to modern people that use very modern platforms that are very useful, and who knows where they will be in 10 years, okay? But so not only we have many development platforms, we also have many places where we distribute the resulting software. Somebody uses a development platform to distribute the software, somebody uses archives, many, many different things. And to make matters worse, over time, projects migrate. So you start it in one place, then you move it to another. If you do your homework well, you usually should close the old one and put in a README saying the new one is there, but not everybody does it. I mean, and so it's not easy to follow the evolution of our software. In a word, what we are sorely missing is a single place where you can actually have a global vision of all the software which is available. What we miss is a place where you can really find, track, and search all the source code, no matter where and how it has been developed, no matter where and how it has been distributed. So that's issue number one. But then you have issue number two, which is our source code, which is software, is actually fragile. Maybe we don't notice, well, maybe a lot of people now notice after what happened 4 years ago, but I mean, we'll come back to that a little bit later on. Of course, you know, digital information is fragile. You can have accidents, your server can break down, you can have an earthquake, you can have a fire, you can make mistakes. I mean, who never actually hit rm-rf in the wrong directory? Raise your hand if you didn't do it. Sure, I know, well, okay, these kind of things. This is well known. But then more recently, you see different kind of problems which are malicious attack. Somebody cracking into your system and just removing everything if you don't ship 150,000 euros in Bitcoins to some specific account. So this is very fashionable lately. But more recently, we have discovered that there is an even greater danger, which is basically business decisions. Okay? In mid-2015, when Gitorios were bought out, in a few weeks, more than 100,000 repositories had to find a new place. When Google Code was shut down, more or less in the same moment, over 1.5 million repositories had to migrate elsewhere. Okay, so this is new. We were not used to this kind of situation. So what we are really, really missing today is an archive, a real archive that has a mission of preserving the content, written in its mission. It's a place where you can go if a repository goes away, a repository was on GitHub or GitLab, or if the platform that you are using for doing development goes away or has failed backups. And the third question is, if you look at the software we are developing, now there is an incredible amount of software which is available for everybody to study, to understand, to look at, and we have many things to do: automatic analysis, bug analysis, trend analysis, vulnerability detection, or something like this. Well, our friends in physics know very well for this kind of big challenges, you need serious instruments to look into this kind of objects. But today, we should copy what people do in physics. I mean, build large telescope to look at the stars. Where is the large telescope to look at our source code and study it, understand how it evolves? So these are just 3 issues we face, and we need to take action. So to take action now, we started with Stefano quite a long time ago. I mean, it was undercover for a while. A project which is called Software Heritage that has the precise mission. It is carved in stone. Our mission is not to become rich, is not to become famous. Our mission is to collect, organize, preserve, and share all of the source code which is publicly available. And we want to do it because it is important to preserve the old source code, of course, but it is even more important to have a single place where you can actually study and enhance the software we are building today to prepare for a better future later on. Okay. But now, how would you do something like this? That's a nice motivation. Let's see what these guys actually do. Okay? But first of all, you sit down and try to think about what the best way of organizing a project like this one. So one idea is to take a little bit of Unix philosophy, so let's do one thing and do one thing well. So what we want to build is really a common infrastructure, a common platform that only cares about this source code. And then on top of this, we want to enable other people to develop a wealth of applications that can be related to cultural heritage, to industry, to research, to education. Just to give a couple of examples, think about what you can do if you have a universal reference catalog of all the software that has been built with all of the history of its development. Okay? The kind of analysis, the kind of study you can do, the other ways of building software that you can develop. For research, having a single place where research software can actually be put and reused by other people who care about reproducibility. For people doing research on software, having a single place where in a uniform way, everything is available to perform your research in a repeatable way. And there are many, many other applications. We don't want to do it. We want to enable it. I mean, it's an infrastructure for doing all this. But that's not an easy task. How can you sustain such a project? How can you organize such a project? So we have 2 basic principles. First of all, of course, coming from the community which is ours, it's evident we want to have everything as open source software. 100% of all the development of the infrastructure we are building is available as free and open source software. But also, we highly value transparency. We do not believe we are the strongest in the world and we take decision it will be the best one. We want to have other people coming and working with us to find the best way of making progress. And on the other side, we are really here for the long haul. I mean, it will take time to build such an infrastructure. It will take time to make it sustainable over time. And the only solution to make sure this project will last over time is to use basic principles of reliability engineering, which is basically replication. Okay? So replication at all levels. We should not just have a copy of our data ourselves. We should create a network of mirrors that make copies in other places, in other countries, under different legislation, possibly using different technology to make sure if one node disappears, others will be there. But it also means replication in terms of contribution. So not just having a single company or a startup running this. No, we want to build a non-profit, multi-stakeholder organization where many people with different reasons of being there contribute to make it viable. And you see, since we have people from cultural heritage which are interested, and from industry, and from research, and from education, we do hope to bring around the table many people coming from different places for different reasons, and they should never go away altogether. I do not want to see, again, a single manager that says, what this project I have here, let's scratch it, okay? And then you have to move another million repository somewhere else. So all of this is nice and fine. It is a high-level vision of what you're doing. Now I think you are curious to know what we are doing technically inside, how far we went. And is this just slideware and vaporware, or is this actually software and hardware running? And here enters Stefano, who will give you a very nice view of what is going on.
Thanks. So let's dive into the specifics of what we're doing and how we are doing it. So first of all, what we do actually archive and what is in the scope of our archival mission. So we go after places where we know we will find source code, and specifically publicly available source code. And so what we go after practically are publicly available version control system, as well as source code distribution artifacts, such as tarballs or distribution source packages. And when we find those places, what we retrieve from those places are actual file content, also known as blobs. We call these content objects. We retrieve commits, because we think that source code itself is very important, but the history of its development is important as well as knowledge that tells you why specific changes has been made in a specific piece of code. So we archive all commits that we find, that we call revisions, with all their metadata. So commit messages, author information, information about which were the previous commits, so on and so forth. We archive releases, that is specifically annotated commits that author considered to be worthwhile for a specific software release with a given name and a given version number. And we archive for all those information, the information about where we have found it, which we call software origins, and when we have found it. So for each object we add to our archive, we note down, we have seen that in that specific repository or in that specific distribution package at that specific time. All this is stored in a canonical model, which I'll describe in a bit in more detail, but which is independent of specific version control system technology or packaging representation. So different VCS, different distribution packages, all stored in the same model. What we do not archive, for now at least, trying to focus on doing one thing for the moment, is we don't store on-page, website of project, wikis. We don't store bug tracking system information or issues or the history of code reviews, for instance, and we don't store mailing lists. So for now, it's to focus on a single mission, but in the medium long term, our idea is that we basically should play one role in a more general semantic Wikipedia of software, where the information we store will be linked to information stored by other people, other archiving initiatives, by saying at the time that source code was archived, well, the website of the corresponding project looked like this. And the same you can imagine for issues, for bugs, and for code reviews, and so on and so forth. So this is what we actually archive. And how does it work? So it's a pretty standard search engine-like architecture implemented as a two-tier process. So on the left here, you have all the places where source code can be found. So you can imagine the major centralized hosting platforms. You can imagine specific instances of hosting platforms you can deploy yourself on premise. You can imagine distribution with their source code packages, and you can imagine the specific repository that exists behind language-specific package manager, for instance. And all those conceptual places are processed by a components that we call listers. And what they do is they go after a specific forge and can do either complete, a full listing of all the repositories available there, or incremental listings, saying something like, what new repository have been created since the last time I've been there. And the result of those listers are stored in our database as points, which we call software origin, and each point is actually a single repository or a single package. So you can imagine here that for any repository on GitHub or on Bitbucket, we have created a data point with a canonical URL where we can retrieve code from, and we keep that in mind for future processing with the second tier of this process. This happens periodically. Okay, and what we develop in terms of code is a specific lister for every specific hosting place. So we will have a lister for GitHub, one for Bitbucket, one for GitLab, and for GitLab, this lister will list different GitLab instances available out there. So this is step one. It is now a pool model, so we periodically redo that, but in theory, it could also be pushed when we receive notification from partnering hosting platforms about the new events. And the second step is periodic as well, and is actually loading. So we go after any specific software origin we have stored here, and we use a loader component to retrieve all the content that is available from that repository, for instance. So we retrieve all the commits, all the revisions, all the blobs, and what we do, we add that to our archive, deduplicating everything globally. So when we find a new commit in a specific repository, we check whether we have already archived that commit, for instance, from a different repository, and we add it to the archive only if that's the first time that we have seen it. Okay? So this model is the canonical model in which we store everything, where everything is essentially stored only once, massively deduplicated, and is implemented as two different conceptual parts, a Merkle DAG and a blob storage. So for those of you that might not be familiar with what a Merkle structure is a data structure that might be a tree, a list, or a DAG, as in our case, which is essentially a hash of hashes. So each node in these structures has an identifier which is not chosen by you when you add stuff, but is intrinsic. So the identifier of a given node is computed by the content of the node itself and by the identifiers of the node that are pointed by these specific nodes. It's a very specific, very common cryptographic construction that you find in a lot of technology these days. You find it at the basis of Git, you find it in blockchains, you find it in IPFS. It's very popular, and it has some very nice properties. For instance, it allows to compare to a huge structure very quickly if they differ in only some specific places. Because, for instance, if the root identifier of two huge graphs of two huge trees are the same, you know that the entire content of the trees are the same, assuming that the data structure is consistent. And also, of course, it supports built-in deduplication, because when you add something, it has a predefined identifier based on its content. And so if the node is already there, you just don't store an additional copy of it anymore. So we use this in the DAG variant, because in commit history, you might have actually known tree substructures. And an example of the kind of nodes we have in our archive, this is a revision node. It's a commit, which has been done actually on our own forge by Nicolas, which is one of our fellow engineers. And all the information of the commits, so the tree, the directory that existed at the time when it was committed, the parent commit, the author, the committer, which might differ if you have someone else pushing the code that you've committed yourself. The commit message is used to compute the ID of the node, and that ID will be the ID we have in our archive for this specific node. So in passing, I know that our IDs for now are compatible with Git itself. It's not a long-term design decision, but given the popularity of Git, it's a good property to have today. So if you have object IDs coming from Git, you can use them directly to check if something is present in our archive or not. So that was a specific node. The conceptual structure of our archive as a whole is then a huge graph in which you have blobs here. So those are the individual content of files without their names, just identified by the hash of their content. You have directories pointing to blobs. You have commit, these are the directory structures, okay? These are the revision, so the commit history, which are usually chained together in a long history starting from the oldest commit to the most recent one with branches and merges in there. And you have releases, which are specifically annotated commits declared by the developer as important commits corresponding to software releases, and you have snapshots. So snapshots are essentially the pictures we take of a given repository when we find it, noting down where each branch or each tag we're pointing to at a time. In terms of, this is a conceptual view. In terms of actual technology, this is implemented as a very simple object storage here, which we have developed in-house. It's all Python 3. And the reason why we have developed one in-house for now is that we don't want to impose any specific technology to people who might want to mirror our archive. But there is no reason why you couldn't have backends for your favorite distributed object storage. And everything else, so essentially the graph structure without the final payload of the files, is actually implemented as a Postgres database. There too, it's been working very well for us up to now. There is no reason why it cannot be great in the future to different structure which are well suited to store graphs. But this is pretty big, so we are skeptical that many technology for storing smaller graphs would be applicable here. So, conceptual view of the archive, what is actually in there today. This is implemented, and it's been mirroring a lot of source code and source code related artifacts in the past months. So in there, in our archive, you will find a full mirror of the public part of GitHub, which is maintained periodically up to date. You will find all the history of source packages uploaded to Debian between 2005 and 2015, which we have injected one off as a dry run, but we will be put in production and with periodic updates in the next few months. Similarly, we have an ingestion of all the tarballs released by the GNU project up to August 2015. Again, one-off run, which will be put in production regularly soon. And we have locally retrieved a full copy of all the repository from Gitorius, thanks to collaboration with the archive team, and a full copy of all the repository that were available on Google Code, thanks to collaboration with Google themselves. So this is not yet injected in the archive itself. We have local copies, but we are in the process of injecting them. For instance, most of the subversion repositories we retrieve from Google Code have been already ingested in our archive, and we hope to finish that soon, in the next few months. In terms of size, all the number you see here are unique objects, because we deduplicate everything. So we have 3 billion different unique files, and I mean unique file content with that. We have something like 700 million commits, and all this is coming from a bit more than 50 million software origins. So you can imagine software origin from now as either packages or either versionless packages or Git or SVN repository we clone and we retrieve code from. On disk is something like 150 terabytes for the blob store, which of course dominates completely the disk occupation, and a 6 terabyte database for the graph. If you think of it as a graph, it's a pretty significant structure. It's a graph which has about 5 billion nodes and 50 billion edges among the nodes, so it's a pretty significant graph in itself. We have reason to believe that this is already the richest source code archive in existence, and as you can see from the grow graph, it's growing daily. So what you can do with that? So starting today, as a token of gratitude for all the communities being here at FOSDEM and all you do for free software, we are opening up our public API. So you can find all the details about our public API at that URL. I should apologize in advance because it's not yet available via IPv6. We are in discussion with our institutional network provider to give us IPv6 blocks, so this will hopefully be fixed in the next few weeks. Okay, so please bear with us until then and use the FOSDEM ancient network here if you want to access it. What you can do with that API, you can essentially browse the content of the archive as a point-wise graph structure. So you can jump from one object to another following the links in the graph. So for instance, you can jump from releases to the pointed revisions to the pointed directories down to the file content. And you have full access for the entire metadata for any objects you are visiting. Okay? Additionally, you have access to all the crawling information. So you can do queries like, when have you last visited these specific Git repositories that I care about? Okay? Or, given a specific visit you have done on a Git repository, where were all those branches that I have pointing to at the time? So it's a sort of wayback machine for your Git and repositories and your source code releases. You have a full endpoint index available and links from the main API documentation. But just to give you an overview, this is a full story you can follow with our API. Let's assume you are a developer of Highlang, which is a Lisp dialect implemented in Python. You can ask, what is the origin identifier for that repository, given the canonical URL of the repository we cloned from? So you have this endpoint here, origin. You give it the type of origin. You give it the URL of the clone URL, and we'll answer you with the ID of the origin. So this is origin ID number 1. Equipped with the origin number, you can jump to the list of visits, and we'll return you a list of all the visits we have done. Specifically, visit number 13 has been done at this timestamp, which is a few months ago. I believe it's something like September 2016. And it will give you the URL where you find more details about that specific visit. So you jump to that, and you will find a huge mapping of all the branches and tags, or refs in Git terminology, and where they were pointing to at the time. So for instance, master branch, we're pointing to the target commit B94, etc., which is actually a revision, okay, a commit, and it will give you the URL to know more about that object. A different tag, the release 0.10.0, was pointing to a release object, and it gives you the URL of that release object. So you drill down, for instance, I followed this release, and I found out the commit it was pointing to, and you will arrive at this revision number, which will tell you all the information about that specific commit. So that commit was done by our friend Paul, which is one of the maintainers of Highlang. We'll tell you information about the date of the commit, the date of the committer date, it might be different in general, and will point you to the directory, so to the root directory associated to that commit. And you can continue. It will give you also the commit message for that specific revision. And you can follow the directory structure down to specific content objects, okay? When you arrive at a content object, you have the information about all the checksum we compute for the contents, which is the SHA-1, the SHA-1 git, and the SHA-256, okay? And we'll give you additional information, which is still work in progress, like detected information like the file type, the language type, and the license type, the license we have detected for the file. And it will give you also a link to the content of the file itself for download. So a couple of caveats apply here, in addition to not having IPv6. So we have rate limits that apply throughout the API that are pretty severe. For now, you can do 120 requests per hour. And blob download, so the actual access to the file itself, is not available yet. This is because we are focusing our resources on developing and adding new features to the archive, rather than in putting energy in keeping up our infrastructure to offer this as a public service for everyone. But we are open to help in case you have resources to offer to actually lift those restrictions in the future. So zooming out a little bit, this is a specific thing we are releasing today, which is navigation of the archive to an API. We had already released in the past a very simple feature accessible from our main website, which will allow you to just drag and drop tarballs or a set of files to see which of those files we have already archived. And in the future, we will be working on a proper web UI, okay, for the equivalent of the API for browser users. We will work, of course, in allowing you to download code from as tarballs or as Git bundles, for instance. And this will be hopefully available in the next few months. And adding provenance information, telling you where we have seen all the places where we have found a specific object or a specific commit. And full text search, of course, because it's really interesting to, once you have this archive, it's super interesting to be able to do full text search of all of it. And much more. So once you have this archive, really the sky is the limit of what you can imagine. And you can help. Okay, so most of the people here are free software enthusiasts and are coders. So this is run as a standard free software project. We have our own forge, we have a development information, we have a mailing list, we have an IRC channel, and all our code is available as free software on our forge, which is a Fabricator instance which we love. In case you're interested in contributing, so these are some of our top development priorities. So of course we need to add more listers for forges out there that we don't track yet. And each type of different forge will need a specific lister. We need loaders for VCS and package format that we don't support yet. We need the web UI itself, which we have a prototype, but it's not ready to be released as a product yet. And of course, there is the ample opportunity of working on indexing content that it is in the archive with whatever indexer you can imagine. So, but of course, all contributions are welcome. So just follow our development channels, show up on our forge, talk with us, and there's definitely something you can do that matches your interest and that will help us in our mission. And of course, you can also join us. So we have opportunities for students, both on development topics and on research topics. And we have actually an open position right now for people who want to work on our web API, or our web UI, sorry. And they are available at this address that you see on the slide. Roberto.
So, thanks a lot, Stefano, for this in-depth presentation of what we are doing. Back to the old guy that brings again the institutional point of view here. Okay? So you see there is interesting technology going on here, and it's an extremely exciting technical project to do this. It's really not easy. Right? It's a lot of work. And here you see a picture of 4 people. So me, Roberto, Stefano there, Nicolas, Antoine. Okay? So these 4 guys have been working like crazy for the last 2 years, I would say, more or less. To try to bring together this first initial part of the project. Clearly, we do not pretend to do this alone. We will never succeed doing this alone. So what is very important for us is to make sure there is a community around it. So first step in building this community was to get support from a national research institution, which is INRIA in France. I don't know how many of you know it, but it's a fantastic place, which is a research center fully dedicated to computer science that has already shown in the past that they have a strong culture in free and open source software. There are a lot of contributions coming from there. And also they are willing to do something which is special, that is to say, help creating new institutions. They were one of the founding partners of the W3C over 20 years ago, and they are ready to do this again. They have put already on the table a lot of resources and energy. We are in their office space, we are using their infrastructure, we are using their services for a lot of things. And so this gives us security for the next few years. But again, it's not enough. We need to bring a lot of people, more people around. And so we have been talking, to partners all around the world, telling them what we are doing, getting mind share, getting support. So all the people in this list are actually supporting the project. I'm sure you will recognize some name. And the red ones here in the first lines are actually people who make a step more by actually providing real resources. These resources can be money, we need it to hire people to offer you jobs, for example. It can be infrastructures, it can be connection with research networks, etc. So you discover some usual suspects in the IT industry, but you have also people from research organizations and from other places in society like banks, for example. Please, if you have connection with these people and these people can come and help, it's very important to have them around the table, as we have said. So to conclude, we do hope we managed to convince you that Software Heritage here is a very exciting new project that has a clear mission, which is not just another project, but something which is really at the service of our community, and through this also at the service of society as a whole. We are very open to collaboration. It's core of our values, and we try to do everything possible to make it easy for other people to come. So you have connection ports to the project that can be institutional if you want to just give money or resources, that are more traditionally in community if you want to collaborate with us, coming internship. If you want to provide time, brain, knowledge, everything is really open to collaboration. You know it's not easy. Creating a community around a project takes time, but as I always say, it's not just a destination, it's a journey, okay, which is important. And so I believe we should see more people coming and try to work together on this project, which is not just our project, it is our project as a community. So I think I will stop here, and we all thank you very much for your attention.
I have a bunch of questions. The first one is about software that was written in DED that wasn't open source, where the company that wrote the software died. Like I'm thinking about something like VisiCalc. They wrote something that was the first spreadsheet. You don't have the source code. You don't have the source code. Are you guys open up on doing stuff that the archive.org people are doing, which is reverse engineering these things to get the source code and archive it? Or you have issues with the legal part of it and are thinking that these pieces of software are dead and long gone? That's my first question. And my second question is, you have 150 terabytes of data. How do you maintain that on the long term, knowing that for NASA, for instance, their image system, they have cartridges, and it takes them 7 years to copy the complete archive to a new system, and when they're done copying, the new system is obsolete already. What's your plan for that? Thank you.
Okay, thanks. Two very interesting questions. One thing is the archive open only to free and open source software or also to other source code? And what about software for which we do not have source code? Again, Unix philosophy, we focus exactly and only on collecting, storing, and preserving the source code. So it's not our business to do reverse engineering or something which comes out. But if you do the reverse engineering and you have the legal rights of depositing it, that's okay. Okay, we get it.
There's a part of archive.org that does that.
Yes, I know.
They're reverse engineering old able software engaged in protection, and they're posting it online.
Yeah, but they mostly.
So he said that there is a part of archive.org doing reverse engineering and posting the result of the reverse engineering.
Yeah, okay.
You're repeating the question because you didn't have a mic. So.
Okay. So again, but the point is to provide an infrastructure that can store all this kind of source code, and all initiatives that can provide new contents are welcome. But we are bound again by legal issues, as you said. So we can only accept software that we can copy. So for example, of course, you will find in the archive software which is not free software, our basic requirement is that we can copy it, and then somebody can do something useful. The minimal useful thing you can do with software, as you see very well in source code, is read it. Okay, even just reading it, that's enough for us. That will come in. That was question number one. The question number two is long-term reliability of all this. Again, as I said, the destination is important, but we are in the middle of a journey. We are not there yet. So for now, the size of the archive is not so impressive after all. I mean, it's very costly if you want to maintain it yourself. But if you look at all the movies or cuts which are uploaded by my kids every now and then.
It's not YouTube size. It's big, but it's not YouTube size.
And so there is this issue of really, really long-term preservation. I do believe much more in a network of mirrors and these mirrors using different technologies. But one thing we are doing, we are talking to libraries, for example, and these libraries have a mission to archive digital content and specific legislation, etc. And they have a very structured process to actually make copy to tapes and make sure these tapes are changed when the technology changes, etc. Again, not our main mission right here, but again, collaboration with other entities, they try to do this. And we are starting making these connections.
I have a question here.
Can you raise your hand?
Yes, I'm standing up here.
Okay, thanks. Hey.
It's a twofold question. It's related to the right to be forgotten and also to problems that you can create when people don't want their codes to be public anymore. So like happened to Gmain a few months ago, some crazy community somewhere in Asia, India, I don't know, decided that they weren't happy with the site and they attacked the site, put it down. So do you have any thought about the idea of people not wanting it to be free anymore, or if it offends someone or a community, the fact that it's free? I don't know, something in the sense of a way out of your solution.
Right, so of course we will abide to the law or regulation that apply where the software is hosted, which right now hosted in France, and in Europe I believe we have the most strict regulation on the right to be forgotten and whatnot. So what we will do is that we already have a legal page information on our website, and if there is any applicable law either for what you mentioned or for copyright infringement, we will just hide the content. So the content will no longer be available for download. We will keep a copy of it if the law allows us to do so. So for instance, if the rights expire one day, we will be able to distribute it again. Which doesn't apply to your case, of course, but might apply to other law regulations.
So I made a couple of notes about your data model. They're like details, but you're going to have to change the data model occasionally. You're obviously going to want to change to a different hash function. Do you have like a transition plan for how to upgrade from old to new with more data in the commit objects or whatever?
Right, so we are already resistant to SHA-1 collision because I didn't show the details, but for blobs we are computing 3 kind of hashes and we have unique indexes on each of them, so we will spot if there is a SHA-1 collision. But of course it will evolve, and the idea is that we will have versioning on the scheme we use for our identifiers. So for now, SHA-1 is doing well. There are no well-known SHA-1 collision in the wild, but they will arrive at some point. And the idea that we will have new releases of our identifier scheme and switch to a bigger hash function or a better hash function. So for the fun technological fact, the only reason we don't have SHA-3 yet is that when we started, there wasn't yet a pretty decent SHA-3 implementation in the Python standard library, but in the version of our stable releases we are using. But we are ready to actually add that into the mix as well, and maybe just adopt that as main identifier for the time being.
We are waiting for the first SHA-1 collision to publish a paper as soon as possible. I mean, in a security conference, we found it.
I have two questions. First one is, if I am a user of this archive, how do I find a better source code in there? Will there be some ranking system or some distinction that I can take as a sign to find a better source code, which I'm actually interested in? And the second question is, how do you make money? Would you make money to support all this infrastructure and your work? Will it be donations like Wikipedia or something else? Thank you.
Okay, very, very interesting. 2 questions. So the first one is how, your first question is a potential very interesting use case. Now that you have this fantastic place where all the source code is available in a uniform way, let me stress it again. And the value added here is that you have a uniform view of the source code no matter where it has been developed, etc. Now that you have this, how can I ask a smart question like, for example, I'm writing HTTP server number 32 because I prefer to write another one. Where could I find a piece of code which is relevant to what I'm doing? Okay. That's a potential application that can be built on top of the archive. It is not our mission to do this application, but it is our mission to make sure you have everything necessary to build it. Okay. And there are people doing work in this. I mean, if you are interested in this, I can give you pointers to researchers working in that particular direction there. The challenge here is to scale. I mean, the scale is much bigger than what you see in this kind of thing. Time's up. And final question, very quickly.
Yeah, here. I have one question.
I should answer the last question here.
Oh, yeah, okay.
There was a second part, very quickly. Yeah. So how we find the money, you are right. We need to eat at the end of the month, have everybody. But you see, our strategy is replication, if you remember. So we are building something which I believe is valuable to many different parties. So the idea is to have a common infrastructure where many different stakeholders put energy to make it stay. It is not just for industry, not just for science, not just for education, not just for culture, for everything. So we are trying to talk to everybody, and that should make it sufficient to make it work. So time's up, I understand, or do you want? Oh,
okay, last question, go ahead.
Yeah, my last question would be, you make own comments where you find it, where you, when you find it, this archive you pull, do you give other options for historical reasons, some commons ability maybe in future? So for historical listing, because what you do is a historical view on source code. So it would be maybe an idea to also give an additional historical comment of some sort. Yeah, is it in your plans?
That's definitely a thing we want to see. I mean, it's in this semantic Wikipedia software that Stefano mentioned. The point is to make sure we connect with other initiatives like Wikidata, Wikimedia, other people who are doing serious studies on this. The Computer History Museum, the Internet Archive, or something like this, to make sure that you find extra information on the source code and you connect it to what we are doing. But again, our main goal is just focus on the source code and make sure we connect with the other initiative. Don't try to reinvent the wheel, just connect with other people.
Okay, thank you.
Okay, thanks a lot for your interest.
Thanks for your attention.
All right. Thank you, Roberto and Stefano. We have a little gift for you, so thank you.
Thanks.
Enjoy, and thanks for your talk.
A lot of questions before there were none.
Yeah, it's all.
Last year. I missed that point last year.
So what do you think? It's super exciting to me.
It sounds great. I have a couple of tiny little quibbles, I think, with your data model. So 2 of them about timestamps. You, I infer, aren't currently recording the timestamps that you get out of, say, a tarball or a Debian source package.
We are.
You are recording?
We are.
Jolly good.
We are.
Because it turns out that those are important.
Yeah, so we have actually, there are 2 kinds of timestamps. One is our own timestamp, which is like the wall clock when you do the video. Right. And people will have to trust us that we said, we have seen that, we are the source of authority. Right. The other one are all the timestamps that are in the object themselves. For instance, Debian packages. When we inject Debian source packages, we extract the timestamp of the change log for the last entry, and we store them as additional metadata.
What about the timestamps of the individual files?
We don't store that at the time. We store the...
You need to store that.
Yeah, I agree. So they actually, what is difficult is to find the right balance between all the data you store and what matters to compute the node ID.
Right.
So what is actually subject to the hash function you use to compute. Right. And that's a pretty hard balance to find.
That's awkward because ideally you would like
the node ID of a tarball and of the corresponding Git thing to be the same.
The problem is that Git doesn't store.